live. All right, so welcome to geometry test number 2 review. Today's 12-12 all day, Thursday, the day before your final test, but not your final. Your final is next week. Portfolios are due Monday. They have been for a while now. Has not changed. The day grows ever near. Don't screw that up. It's 10% of your final grade, right? So.
I thought it was 20.
Nope, your final is 20, right? Hold on. Every class has 20% allocated to your final test grade. What I have done is taken that 20%, cut it in half. Your 10% is the test that you're going to take next week, and 10% is your portfolio. Okay? So it means that your final exam, the test,
Is 10% of it.
is half as dangerous as it used to be, right? Okay? But that means you have to do well on your portfolio, otherwise it's going to, you might as well just bomb the final, right? Like, don't screw both up. Make sure both are good, right? I don't know what you're saying. Can you say it again really fast?
In 2012, everybody got excited about today's day because it was like 2012.
Yes. Yep. That was. That definitely happened. All right.
First time in our lifetime.
Okay. So check it out. Let's get going. First page. Vectors. I'm not going to make you graph them. Okay. We know what they are now. We've been using them all the time. The question is, which ones are parallel, right? And what is the magnitude? So I'm going to go over how to find out if they're parallel or not. We're comparing their components like their slope. So check it out. V is 4 over -2 for its slope, right? Rise over run is basically what the slope is. That reduces to -2, right? 4 divided by -2 is -2. Now, I'm going to cheat a little bit because I know the answers. Oh my God, I'm missing so many things. I brought some from home just in case. Also, my Secret Santa brought me Sharpies yesterday. That was convenient. So, I love this. We need to find another one that's -2 when we simplify. And guess what? None of them are. Great. Good job, Mr. Mac. This one right here is -3 over 3, which reduces to -1. Right? So it has a slope of -1. Are these going to be parallel, these two? No, because they have different slopes. This one over here, I am running out of colors. Ladies, I need you to bring me some pens back. Like, give me some colors. I need blue. I need the colors I regularly use. Thank you. All right. This one is 3 over -3, which also reduces to -1. So those two will be parallel. Purple? I need purple. Thank you. Oh, okay. So these two will be parallel. So the way we write that is we say that A, vector A, thank you, is going to be parallel to vector D. Okay? So you're going to tell me which ones are parallel, which ones aren't. They're parallel if they have the same slope. I hope everybody's cool with that right now. Now to find their magnitude, remember we're talking about how long these things are, right? In length is distance. So we're going to use distance formula, otherwise known as the Pythagorean Theorem, right? So we're going to take their components and do Pythag with them. So let's look at vector V. To find its magnitude, its length, we're going to take -2 and square it, and then we're going to add it with 4 squared, and then root it. Because that's Pythag, right? That's going to get us C. Cool. So when we do that, we get 4 here and 16 there. Remember, to square something means to times it by itself. So -2 times itself is going to be a +4, because 2 negatives make a positive. 4 squared is 16. Still we need to root it. That's 20 together, so root 20 is how long that is. If I got root 25, I can simplify that to 5 because the root of 25 is 5, but root 20 isn't anything cool, right? So we just leave it as is. Yes?
Why 4 squared?
Because that's the components of V. -2 and 4. Good question.
Will I do any of them for those?
What I'll say is you need to find it for all of them. Now,
Okay.
guess what I'll do? I'll probably give you 2 of these tomorrow, and I'll say, are they parallel, are they not? Right? And then I'll say, find the magnitude.
Yeah.
Save you time, right? You do it for 2, you can do it for all. I just want to give you lots of examples to practice on, right? Okay. How do we feel? I want this to be something that you knock out of the park this first date, right? Please do. Don't screw it up. Whack.
It's not tomorrow's test.
It's tomorrow's test.
Tomorrow's Friday.
Jenna?
How did you get the 4 again?
I took its components and I put them into Pythagorean Theorem. So -2 and 4.
Okay.
-2 squared is 4. 4 squared is 16. Add them together, you get 20. So root 20 is the answer. That's how long it would be. Okay? the point across the line. So, here it is. There's our line. Let's graph it. Looks like a y-intercept at -2, a slope of up 1 over 1, right? That's the slope for this one is 1 over 1. Does everybody see that in front of the x? There's a 1 there, right? So we go up 1 over 1, and we keep doing that, and that's going to be our slope. Ladies and gentlemen, I'm going to go quickly so we can get through all of this. I would highly encourage you not to write this stuff down and to write it down later after watching the video at home, or take a screenshot at an opportune moment, okay? Make sure you're understanding what's happening more so than writing it down. Understanding is always more important, right? Here's -2, -7. 1, 2, 3, 4, 5, 6, 7. That's A. We're going to reflect that point across this blue line. In order to do that, I need to find a perpendicular line that goes through this point. Starting to come back to you? So to find the perpendicular line, I need to take the original slope, flip it, negate it, right? So when I flip that, it's 1 over 1, right? When I flip it, it's still 1 over 1, and then I negate it. So our perpendicular line is going to be y equals -x, right? -1 over 1x. And then we need to figure out what the y-intercept has to be, that b value, so that it actually goes through A. Remember, this line represents any line that's going to hit it at 90. We want the one that hits it at 90 and goes through A. So what would it have to hit here to go through A? Well, it looks like it's going to be like negative something right here, right? But we need to figure that out for sure. So the way we find that is we say, look, I know I want this line to go through this point. So when I plug in -2 to its equation, I should get -7 for y, right? So the question is, what does B have to be to make that happen? And the way I'm going to figure that out is I'm going to plug in those points for y and for x. Now, remember, when we're plugging in numbers, make sure you wrap them in parentheses. That way you realize that it's a negative version of -2, right? -2 is what x is. That's what we're plugging in. And we want to negate that. Don't make the mistake of only writing one negative sign in there. There's already a negative, and then there's a negative coming from the number as well, right? So now we do math. We get 2 here. And then we subtract that 2, and we find out that b is -9. Which means that y is going to equal -x minus 9. So that is our perpendicular line. To graph that, I'm going to go down 9. And then I'm going to use my slope, down 1 over 1. And when I do that, that creates this line. Notice this line definitely goes through A. And since it has perpendicular slope, we know it definitely hits the blue line at 90 degrees. So there's our line. And the reason we do this is because when we flip A over the mirror, we know it's going to be somewhere on that line, right? Has to be. Reflections happen perpendicular to the mirror. As I move, mirror me moves, and it's always at 90-degree angles. So A prime is going to be somewhere over there. If you're clever, you can probably eyeball it, right? But I need to see the work. How we feel so far? Flip and change the slope, solve for B. Ah, that's right, because you learned it for real last time. Yes.
Why is it down 1 over 1?
Because the slope before was 1 over 1. Flip it, negate it. -1 over 1. Good question. All right. I'll let you guys. All right, so next thing we're going to do is figure out where they intersect. Why? Because where they intersect is going to be the halfway point between A and wherever A prime is, right? Reflections are always the same distance from the mirror, right? So where they intersect is where they equal each other. So I'm going to set these two equations equal. See how y equals x minus 2? Well, if y equals x minus 2, can't I substitute it down here? So I'm going to do that. I'm going to write x minus 2 equals -x minus 9. And where they equal each other is where they agree. In other words, where they intersect, right? So let's do some math. I'm going to put my x over here, and it's 2 x's now. And I'm going to add 2 to this side, and I get -7. Ugh. Now we're going to divide. X equals -7 over 2. Gross. It's going to be fine. So that means our midpoint, where they intersect, M, is going to be -7 over 2 comma something. How do we find the other something, the y value? what do we do?
Plug it into one of the.
We plug it into either equation. I'm going to plug it into the top one because that looks easier for me to do. So when I plug that in, y is going to equal negative 7 halves x, I'm sorry, it's negative 7 halves minus 2. So now we need common denominators to be able to subtract them, and we're going to get our answer for y, okay? How many halves are in the number 2?
4.
4 halves. Now check your work. Is 4 divided by 2 2? Yeah, so we didn't change the problem, we just made it look different, right? And now that we see they're talking about the same thing, we can put them together. So y is going to equal negative 11 halves, because negative 7 minus 4 is negative 11. Yuck, but it's going to be fine. All right, so that's m. It's halfway between a and wherever a prime should be. You with me? All right, so here's what we're going to do. We're now going to reflect that point. And the way we do this is use midpoint formula. Midpoint formula is what? Average of the x's, average of the y's. When we average stuff, do we add or subtract? Add them up, and then what do we do? Divide by the number of pieces. All right. So we know midpoint is going to equal our x's added up and our y's added up divided by 2, because there's 2 pieces each. Now we know one of our x's and one of our y's, don't we? That's what a is. A is one of these points. A prime is the one we don't know, right? So a was negative 2 and negative 7. How do you solve a problem like Maria? Well, the whole point is to get x and y on their own, right? We want to find out what x and y are. So ignore this for a second. To get x on its own, 2 things are bothering it. 1, the divides by 2. We know how to get rid of that. And 2, this plus negative 2. In other words, just minus 2, right? You know how to get rid of minus 2? Yeah. Add 2, right? So let's get rid of division first to make a better world, right? How do we get rid of division? Division is divorce. We're going to do divorce by multiplication. Right? So we're going to multiply by 2 to both sides. So we know that negative 7 halves equals x2 minus 2 over 2, right? These 2 equal each other. So here's how I'm going to solve this. I'm going to times by 2 to both sides. Now, magic is going to happen here. When I times by 2 to both sides, what happens? Well, this cancels, because that's what we did, right? And then on this side, it's negative 7 divided by 2 times 2. Don't division and multiplication cancel? So I just get negative 7. Our fractions are gone. That's good. I'm going to add 2 to that, and then I get negative 5. So a prime is going to be negative 5 comma something. To find the y value, it's going to be from this side, right? So negative 11 over 2 is going to equal y2 plus a negative 7. I can write that more simply, right? Instead of plus negative 7, what can I write? Minus 7. All over 2. Again, when we multiply by 2 to both sides, our fractions go away because they're both divides by 2, right? So that's really convenient. Thank you, Mr. Mack, for making the problem like this. Then we're going to add 7. When we do that, we get negative 4 equals y2. So that's negative 4. A prime should be at negative 5, negative 4. And if you look on your graph, 1, 2, 3, 4, 5, down 4. Oh, yeah. On the line, same distance on both sides. Looking good. Distance here is the same as the distance there. Sorry, my squiggles were estimations. Ignore these squiggles. Same distance on both sides, yeah. On the line, perfect reflection. How do you feel? Remember when this was really, really hard and now it's just sort of hard? Okay. Arithmetic, right? Calculation, hard. Making sure you don't mess up the negatives and the positives and multiplying wrong, right? Don't say 3 times 2 is 5, right? That's hard. But the rest of it I think you guys get. Next page. Same dumb crap, so we're going to skip it. Same dumb crap. This one's going to be a little bit harder because you're going to need to get common denominators to add fractions, okay? But that's it. Next page. Number 4. Another one, okay? Same dumb crap. This one's going to be tough because it's going to be more of that fraction stuff, okay? Again, giving you more chance to try it out. We can talk about adding and subtracting fractions now if you want. I'll do a quick refresher, okay? So, Multiplying fractions ain't no thing, right? If I've got 2/3 times 2, super easy to do. I've got 2/3 and I double it. How many thirds do I have now? 4/3, right? Again, the way we can look at this is we can say 2 times 2 is 4, and then what's 4 divided by 3? 4/3, right? Fractions are division for lazy people. What's 4 divided by 3? 4/3. What's 5 divided by 2? 5/2. You're done. Super lazy division, right? But it's the right answer. Another way we can think of it is say, what's 2 divided by 3? Well, 2/3. And then I have to double it. 4/3. Doesn't matter how you want to think about it. Divide by the bottom, times by the top, any order you want. Feeling good? Let's make this a little bit harder. What if we're multiplying a fraction by another fraction? Do we need common denominators?
No.
Nope, we don't. Because all this is division multiplication, right? Cool. So we're going to take 2 and double it. What do we get? 4. Okay? So we got 4 divided by 3. What's 4 divided by 3? 4/3. Now we're going to divide it by 5. Oh, God. 4/3, and we're going to divide it by 5. Okay? Don't write this. I just wanted to write it down so we know what we're doing right. Okay? If we take something and we divide it by 3, I have that, right? What if I divide it by 5 after I divide it by 3? How many pieces do I have here? 15. So dividing something by 3 and then dividing it by 5 is the same thing as just dividing it by 15. Right? Think about it. I cut something in half, and I cut it in half again. Isn't that the same as cutting it into 4s? Why not just divide it by 4 to begin with, right? If I cut it into 3 pieces, and then I cut it into 5 pieces, I've really cut it into 15. Yeah?
Why can't we divide it just 2 times 2 and 3 times 4?
You can, and I'm showing you why that works. Why does this work? 2 times 2 is 4, 3 times 5 is 15. Because of this. 2 times 2 is 4, divided by 3 is 4/3, divided by 5 is 15ths, right? How do you feel? We multiply across, not cross. We never do that. That's a lie, it's stupid, it's dumb. Across is how we multiply. Feeling good? All right, now let's talk about adding and subtracting fractions. This is when we do need common denominators, right? So if I've got 2/3 plus 2, are they talking about the same thing? No. One's ones, right? 2 ones. And the other is 2/3. So we need common denominators. The way I think of this, whenever I see a regular number like this, I just do it in my head. How many thirds are in 2? 6 thirds. Right? And check your answer. Is 6 divided by 3 2? Yeah. So we didn't change it, we just made it look different. If you can't do how many thirds are in 2 in your head, ask yourself how many thirds are in the number 1. Well, 3/3, of course, right? So how many thirds would be in the number 2? Well, there would have to be twice as many, so 6 thirds. Now we can add them because they're talking about the same thing. How many thirds do we have total here? 8 thirds, right? Done. Subtraction. Addition. Need common denominators. Let's do 2/3 plus 3/4. Are they talking about the same thing? Nope, so we need common denominators. What's the common denominator between 3 and 4? 12. Easiest way to find a common is multiplying, right? And the reason for that is 3 times what gets us 12? 4. So we should multiply the top by 4, and we're good. Why does this work? Check it out. If we multiply a number by 1, does that ever change anything? No. So we multiply 1 as much as we want, right? If I multiply that by 1, does it change the problem? No. What if I multiply by 2/2? Does that change the problem?
Oh, no.
It doesn't. Why?
Because 2/2 is...
It's the same thing as 1. It's just a different way of looking at it. What we wanted to multiply by was 4 on the bottom. Now, if I just do that, that's going to change the problem, right? But if I multiply by 4 on the top and the bottom, that's just multiplying by 1. So when we say 3 times 4 is 12, right? Well, I have to do it to the top as well, otherwise it changes the problem, right? I got to balance it out. Because if I times it by 4 to the top and the bottom, it's the same as multiplying by 4 before, which is 1. Here, 4 times what gets me 12? 3. So I need to multiply the top by 3 as well. Are we talking about the same thing now? Yes. How many 12s total do I have?
17.
17 12s. 8 plus 9. Feeling better? Okay. Moving on. Let's go to number 6. Translations. We are not going to write down the coordinates. You can do that in your own time. It says, provide all coordinates and the rule for the given translation. So we're going from A to A prime, right? So check it out. This is the vector I'm using. What vector is that going to be? Looks like 1, 2, 3, 4, 5, 6 to the right, so that's 6. And how much up? 1, 2, 3, 4. So that's my vector, right? So I'm moving it 6 to the right, 4 up. So what's my rule going to be? X plus what? X plus 6 and Y plus 4. What I would do is I'd write down these 3 coordinates, and then I'd do that and just get those guys for free, right? How do you feel? That's translations. Remember when that was hard? Moving on. Number 8. Provide all coordinates in the rule for the given reflection, and then plot the reflection. So you need to graph it. Well, check it out. This is an easy reflection. It's right over the axis, right? So here's what we got to do. B is 3 away, right? We're flipping it this direction. What kind of a flip is that? Is it horizontal or vertical? Vertical, right? So it needs to be 3 away vertically from the axis, right? So afterwards it needs to be 3 away. These are easy reflections. We don't have to draw a perpendicular line and all that crap, right? We can just eyeball it. How far away is A from the axis? 1, 2, 3, 4, 5, 6. So it needs to be 6 away on the other side, right? 1, 2, 3, 4, 5, 6. And there's A prime. Now, I could write down those coordinates, and then I'm good to go. But we need to know the rule. If I write down the coordinates, I can probably see what's going on there, right? We're going to negate one of them, right? But what is the rule for a flip across the x-axis, otherwise known as a vertical flip? If it's a vertical flip, which one do we negate? The y. Vertical flip, right? Which variable deals with vertical? The y value, right? So we're going to keep x the same, and we're going to negate the y. That's it. It's a vertical flip. And it's a perfect vertical flip right with the axis. Number 9 is a horizontal flip. So our rule is going to be negate the x, right? However, is this the y-axis? No. So we need to adjust for that. So let's check this out. If I've got A here, it's 1, 2, 3, 4, 5 away from the line, right? So when I flip it, it's going to be 5 away on the other side. 1, 2, 3, 4, 5. A is here. A's original coordinates were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left. I'm counting from the origin, right? And 1, 2, 3, 4, 5, 6 up. A prime ended up on 0, 1, 2, 3, 4, 5, 6 up. Now you'll notice our rule of just negating the x ain't gonna cut it, right? It's not. And that's because this thing isn't down the y-axis, right? So we have to adjust it. After we negate it, we get positive 10, right? So what do I have to do to positive 10 to make it into a 0? I have to slide it, right? So what do? Subtract 10. So my rule is negate the x, and then after you do that, subtract 10 from it. That's going to adjust it for this switched line of reflection. Does that start to come back to you? Right? So that's our rule. We don't change the y at all because it's a horizontal reflection, right? We're flipping this way. How do you feel? Other than the perpendicular line thing we did earlier that took a long time, these should be gimme points.
Wait, why did we negate the x?
Horizontal flip. Whereas up here we did a vertical flip, so we negated the y. Notice this one was perfectly over the axis, right? The line of reflection was the axis, so we had no adjustment to do. Here, because it's 5 to the left, we have to do a minus 10. There's something about that, but don't think too hard, okay? Ask yourself, after I negate that, what do I have to do to make it a 0? Subtract 10, right? Yes?
Well, I was just going to ask why it was 10, not
10
9.
and not 5?
Yeah.
It has to do with reflections being symmetrical, and so it's going to be twice as much as you are apart. But don't worry about that, okay? Walk yourself to the line. I love that job. Next page, number 10. 180 degrees about R. Oh God, I don't want to draw all those L's. That would be terrible. Okay, then don't. Let's find the rule first. Is r on 0, 0? No, so we have to move it to 0, 0. So everything is going to move by this vector. What vector are we moving everything by? Looks like 3 to the right and 2 down. Now that it's on the origin, we're rotating 180 degrees. What's the rule for a 180 degree rotation? What's the rule for that?
Negate x's and
Do we flop x and y? No. Think about it. Or plane. There's your L. When I turn it 180, horizontal goes vertical and then horizontal again, right? After I turn this 180, vertical goes horizontal, then it goes vertical again. Did the horizontal stay horizontal? Did the vertical stay vertical? Then x and y don't switch. Their direction does, though. We were going up here and now we're going down. We were going to the right here and now we're going left. Negate the x, negate the y. Laney.
For the vector, if you're going 3 left and 3 down, would it be -2?
3 to the left and 3 down. Good call, Laney. Thank you very much. Well done. You got people thinking today. All right. Now we got to move it back. 3 to the right and 2 up. So our rule. First, we're going to take x and y, and we're going to subtract 3 and 2 from them, right? And since that's first, we're going to wrap that in parentheses. Do we flip the x and y for this one? No, good. So I don't have to erase it or write it again. That's convenient. What do I do for my rotation? What's the rule? I don't switch them. What do I do? Just negate them. So there we go. And then after that, we gotta move it back, which I actually left room for this time. Thank you. Thank you. Hold your applause. We're gonna add 3 and add 2. So here's what I would do. Don't draw your frickin' L's, right? Plug in those coordinates into this, and when you get them, write them down and graph them. A lot easier than doing a lot of L's, isn't it? Now, the trick is, you have to be good at adding small numbers and subtracting small numbers, right? So don't screw that up. If you need help on this, I can help you, okay? If you make a small mistake, raise your hand, I'll find you. How do we feel? All right. Number 11. 90-degree counterclockwise rotation. Real quick, I'm not going to write the whole rule, but our vector looks like it's going up and to the left. So it's going to be 4 to the left and 1 up. What's the rule for a 90-degree counterclockwise rotation? Here we are. Counterclockwise is this way. Do x and y change spots? Yeah, they do. We're going from double positive to positive, negative positive, right? Which one negates, first or second? First. So flip them and negate them. And we're going to negate the first. So it's going to be negative yx. Then we move it back. So we add 1 and subtract 1. I bet you could write that rule, couldn't you? I'll write it anyway. So, first I'm going to take my x and y, and I'm going to subtract 4 and add 1. Now for this one, unfortunately, I have to switch my x and y, and because I write in pen, I have to switch them all together, right? So I got to rewrite this. Sorry. Takes up time. You see how everything moves with it when I flip them? They were all together before, and they're all together after I move them. Do you see how the y and the 1 move together? And the x and the -4 move together? We flip them, and then we negate them. So I'm going to negate the first. We good? All right. Then, I didn't leave room this time, but I'm going to squeeze it in. I add 4 and -1. There's our rule. Yes?
How did you know to flip them when you did that? I know how you negate it, but how do you know?
See how the horizontal part, when I rotate it, becomes
Oh.
vertical?
Yeah.
That's what's going on there, okay? And that's important because we're going to have to explain what's going on. I had this the other day. I was going to grab the fourth class. Please tell me I still have it over here. It's a finished copy of all the written stuff. Well. Get out of here, Twilight. Be gone, Satan. Right. Oh, it's right here. 12. explain the rule for a 90-degree clockwise rotation, a counterclockwise rotation, blah, 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 blah. Here, this is from our review from the quiz. So here's what I wrote. You can take a picture, okay? I am going to read it, okay? So take a picture now. Explaining a 90-degree clockwise rotation.
Dude, the lights are like not working.
Is that better? Contrast?
Nice.
So, the blue part of my L goes from horizontal to vertical. The red part of my L goes from vertical to horizontal. That means that X and Y switch places. Are you hearing the words I'm saying?
No, can you say it again?
Okay, here we go. And it's on there, right? The blue part of my L goes from horizontal to vertical, right? You can see that. The red part of my L goes from vertical to horizontal, which means that the X and the Y trade spots. You know this. Just write it. Also, the original X becomes negative since it goes from right to down. See how the blue part is going to the right? And now it's going down? Well, right means positive, down means minus, right? So it switched signs. Whereas the red part was pointing up, positive, and now it's pointing to the right, still positive. So it doesn't change signs. That's for a 90-degree clockwise rotation. For a counterclockwise rotation, I didn't have room to write it, but it's the same dumb crap. It's just different ones switch signs, right? What's going to happen is that this red part is going to be pointing to the left when we're done, so it's going to go from positive up to negative left. So Y is going to change the sign, right? For 180 degrees, do our horizontals change from horizontal to vertical? No. Do the verticals change to horizontal? No, they stay vertical. So X and Y don't switch. We were going positively up. After we're done, we're going negatively down. So the sign's going to switch for the Y, right? Negative Y. Is the sign going to switch for the X? Yeah, because it's going to the right, and now it's going to the left. How do you feel? Words are hard, math is easy. Tell me that you know this. Okay? You do. If you need help writing it down, I can help. Okay? But you need to know it. What it means. Explain the rule for reflection of the x-axis and reflection of the y-axis. The words I would use would be this. Horizontal flip, change the x. Vertical flip, change the y. 15. Rotation about an arbitrary point. Take a picture if you want it.
You're confusing me with numbers.
I know, I'm sorry. I'm looking at this. My bad. Since an arbitrary center complicates things, it's easiest to move it back to the origin. We do this with a vector, right? So we move it back to the origin with a vector. Then we do our regular rule, which we've talked about earlier, right? And then we move it back with another vector. That's all that means. I was super thorough. We move it with a vector to the origin to make it easier. Then we do a rotation. Then we move it back to get the real answer. That's all I'm looking for. Can you write that? I know you can. If you need help with this and you can't remember what I said, watch the video. All right. So that was our rotation rules. We explained reflection over x and y axis. And we also talked rotation about an arbitrary point. So now we're on to number 15. Dilate each image by the given rule when it's centered at the origin. So they want you to negate the x and times the y by 3. So what is that going to do? Well, we're centered at the origin. That's what they said, right? How far is C away from the origin to in the horizontal direction? It's 1. We're going to negate that. So it's going to be negative 1 away from it now. You with me? Then it says times the y by 3. How far is C away vertically from the origin? 3. So when we times it by 3, how far is it going to be away? 9. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. C prime is there now. You dig? It was 1 to the right. Now it's going to be negative 1 to the left. It was 3 up. Now it's going to be 9 up. How do you feel? Do that for all the points. This one, 16. Is it going to get bigger or smaller? Smaller. It's going to be half as much in the x direction and a third as much in the y direction. Here's our origin. Let's look at B. How far is B away horizontally from the origin? 2. So when we have that, it's only going to be 1 away. minus 1, right, to the left. It's a 3 away vertically, right? So when we third that, how far is it going to be away? 1. So B prime is going to go here. That's kind of annoying, isn't it? A is 2 away in the horizontal direction. When we have that, what's it going to be? 1 in the horizontal. A is 6 up in the vertical direction. When we third that, what's a third of 6?
3.
Try again, that's half. What's a third of 6? 2. So A prime is going to be there. You can do this. 17. It's going to shrink in some ways and grow in others. So, negative a half. How far is B away from the origin horizontally? 4. When we have that, it's going to be 2, but we got to negate it. So now B is here horizontally. We're not going to mark that yet. How far is B apart vertically? 3. So when we triple that, how far is it going to be apart? 3, 6, 9. Oops. 3, 6. B prime is going to go there. A, how far is it apart horizontally? 4. Have that and negate it. We get negative 2. How far is it apart vertically?
3.
Yep, negative 3. So we're going to triple that and go down 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's A prime. There is your new one. It's longer, right? Because we tripled the Y, like taller, right? And it's not as wide and flipped because we negated and halved the X. Horizontal flip because of the negative. Halved because we shrunk it this way, right? That's 17. 18, dilation centered at the origin. B is 1 to the left and 3 up. After we're done, it's 2 to the left and 6 up. What do? We didn't slide it, we're dilating. We times x by 2 and y by 2. We doubled the distance from the origin, both vertically and horizontally. How do you feel? Number 20. How far is A from the origin? Looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. But after we're done dilating, it's only 1, 2, 3, 4, 5 up. So what do? We have the y. Look at B. It's 1, 2, 3, 4, 5 to the right, horizontally. After we're done, it's only 1 apart horizontally. So what do we do to the x value? We took it and times it by a fifth. No flips, so no negatives, right? B was 5 apart. Now it's 1 apart. 5 times a fifth is 1. Right? We have 5 things. We cut it into fifths. 1 left over. Yes?
For number 18, should it be 1 times x and 1 times y?
I went the wrong direction. 18. Are we going from here to here or here to here? We're getting smaller, aren't we? So we didn't times it by 2. We halved it. Good catch, Taylor. 21. Explain the difference between isometric and non-isometric. What does isometric mean? Isometric. Same size. So is a dilation isometric?
No.
No! All the others are, though. They don't change the size. Moving on.
Okay.
Find the rule for the dilation. How far apart is T from C horizontally? 1, 2, 3, 4, 5, 6. When we're done, it's only 3 away horizontally. So what do we do to the x? We halved it, right? We halved the x. T is 1 away vertically. I'm sorry, 2 away vertically, and it's 1 after we're done. What did we do to the y? We went from 2 to 1. What did we do? We halved the y. Now here's the problem. Is C on the origin? No. So first we have to move to the origin. 2 to the right and 3 down. Then we're going to do our rule. And then we're going to move it back. So what's our rule going to be? It's going to be take x and add 2, take y and subtract 3. Then we're going to have them both. And then we're going to subtract 2 from that and add 3 to that. Add 2 minus 3. Have them both. Subtract 2, add 3. You see where I'm getting my numbers? This one, complicated transformation. First of all, is a dilation alone going to get it done? No. Change the size. See how it's 3 apart vertically, and then we have 1 here? Right? So we're going to need to dilate it by 1/3 in the y direction. Horizontally, it's 4 apart, and it's only 2 when we're done here. So what do we do to the x? We halved it. I would use c as the origin to keep it simple. So that's going to get it to be the right size. That's going to put it somewhere. It's going to put it like here for t prime, and then it's going to put w prime here, and v prime there, and u prime there. So now we're here. Can I just slide it in place? No, I have to flip it, don't I?
What is happening? What?
So check it out. I halved it and thirded it. When I do that to its coordinates, it puts it here, smaller and moved. I'm going to flip it across here. What's the rule for a flip across the y-axis? A horizontal flip? Negate the x. So now we're here. And now they're in the right order. And now I got to slide them. I'm going to use a vector to slide it into place. Let's slide t prime over. So it looks like I'm going 1, 2, 3 to the left, and 1, 2, 3, 4 down. So now I'm going to slide it into place. Subtract 3, subtract 4. They said it couldn't be done. They said it could not be done. I'll slow down. We shrunk it by 1/2 and 1/3. Are we good with that idea? We shrunk it by 1/2 in this direction, so it would be 2. We shrunk it by 1/3 in this direction, so it would be 1. Are we good with that? Now, when you do that, it's going to move it closer to the origin, right? I applied that to its coordinates. T is at 4, 3. So when I have that, it's going to be at 2, and I third that, it's going to be at 1. You with me? Then I flipped it so it would be the right orientation. I negated the x, horizontal flip. Then I slid it into place using a vector, subtract 3, subtract 4. That's the hardest one on here. But it's not hard, it's just a lot. See what I'm saying? There's a difference. So I'll do it again. Third this, halve that. Are we good with that idea? That puts it here because, good question. See how t is 4 to the right and 3 up? When we have 4, it's now at 2. When we third 3, it's now at 1. Better? Then flip it, negate it, right? Horizontal flip, and then slide it into place.
What about this one?
Fully explain a dilation by an arbitrary point. First, we slide the arbitrary point to the center. Then we dilate it. Then we slide it back. That's it! That's it.
Mr. Matt, can you let me pass the phone?
Of course.
Can I come in now?
Yes!
Because I'm confused.
You need a pass too?
No.
Okay.
He doesn't share. Chloe, do you really need that?
Yes.
I haven't made it yet.
It's like, I can finish a quiz during class.
So here's the deal.
Thank you.
I will simplify it as much as possible. Will you be doing translation by, will I make you translate something? Probably not. Even if I do, it'll take 5 seconds, right? I will condense as much as possible. There will be at most 1 question per each page in this packet. I won't ask you to explain the rule for a 90-degree clockwise, counterclockwise, and 180-degree rotation. I'll pick one of them, right? You'll have to explain one of them. I won't tell you to explain a reflection across the x-axis and the y-axis. I'll choose one of them. I won't make you do 10 vectors on the front and find their magnitude. I'll choose 2 of them, right? I'm going to make this small. I know time is at a premium. My rule generally is if I can do it in 5 times as less time as you, showing all my work without any mistakes and in color, then it's fair. My new rule for tomorrow will be 10. You have a 45-minute class, which means I can be able to do it showing all my work in less than 5 minutes.
Oh.
I'm up for the challenge. Which means you should be able to do it in 45, right? This one was really good.
I won't be here tomorrow. I have a doctor's appointment, so when am I going to take this?
Oh man. Monday after school or something? I don't know.
I have basketball.
Yikes. I don't know, man. Like, yeah, you tell me when, I'll make it happen. You want to take it over the weekend? on Monday
Yeah.
in the morning? I don't know. I could be here at 7.
Okay. I'll figure.
Are you gonna be at the review this weekend?
Yeah.
I'll talk to you then, and if you want to stay after, we can do it then too.
Okay.